Welcome! In this video, we'll explore Git debugging techniques. We will see how to troubleshoot common Git problems effectively. Let us get started. Let us examine some common Git issues and debugging approach. Common Git issues include merge conflicts, detached head state, accidental commits, lost changes, and authentication failures. To debug, first check the Git status. Then review the Git log history. Examine the reflog for lost commits, use git config to verify settings, and read error messages carefully. Merge conflicts occur when Git can't automatically reconcile differences between branches. To resolve the conflicts, first identify the conflicting files. Understand conflict markers. Then, edit files to resolve conflicts and mark them as resolved with the git add command. Here's an example of how a conflict appears during a merge. Running the command git merge feature branch results in a merge conflict in file.txt. The conflict markers in the file will look like this. O of head, current branch content, ========================================================================================================================. Incoming branch content, and O feature branch. After resolving the conflicts, use the command git add file.txt, and then git commit and resolve merge conflict. A detached head occurs when you check out a specific commit instead of a branch. Your head points directly to a commit rather than a branch reference. Common causes include checking out a specific commit hash, checking out a tag, or using git checkout head 3. To detect a detached head, use the command git status. The output will show head detached at, followed by a commit hash, and the message you are in detached head state. To fix this, you can create a new branch using git branch new branch, and then git checkout new branch. Alternatively, you can create a branch and checkout in one step, using the command git checkout b recovery branch. To return to the previous branch, use git checkout main, and merge if needed with git merge recovery branch. Sometimes you need to undo mistakes in Git. To discard changes in the working directory, use git checkout file.txt. To unstage a file while keeping the changes, use git restore staged file.txt. To discard all changes, use git reset hard head. Warning: this cannot be undone. To stash changes temporarily, use git stash and git stash pop to restore them later. To amend the most recent commit, use git commit amend. To revert a commit and create a new commit, use git revert head. To undo the last commit while keeping the changes, use git reset head 1. To undo multiple commits, use git reset head 3. For more complex history editing, use interactive rebase with git rebase I head 5. Git's reflog tracks all reference changes in your local repository, including commits that are no longer referenced, branch deletions, reset operations, and rebases and merges. Reflog entries expire after 90 days by default, or 30 days for unreachable commits. To view the reflog history, use the command git reflog. This will display a list of commits with their corresponding head references. To recover a lost commit, use git checkout followed by the commit hash. Then create a new branch with git checkout b recovery branch. To recover after a hard reset, use git reflog to find the appropriate head reference and then use git reset hard head at 1. To find a deleted branch tip, use git reflog and grep for the branch name. Let us discuss troubleshooting authentication issues. Common authentication problems include permission-denied public key errors, invalid username or password credentials, expired personal access tokens, an SSH key not registered with remote, a wrong remote URL protocol, such as HTTPS versus SSH, and credential helper issues. To solve these problems, verify the remote URL with the command git remote v. Update credentials using git credential manager. Test the SSH connection with the command sshttgit at github.com. Update the remote URL protocol using git remote set URL origin followed by the URL. Generate a new SSH key using SSH keygen at 25519. Use credential caching by configuring git config credentialed helper. Git provides several advanced tools to help diagnose complex issues. These include Git bisect for finding bugs, Git blame for tracking changes, Git debug for verbose output, Git fsck for repository integrity, and Git gc for repository optimization. To find which commit introduced a bug, use Git bisect start, Git bisect bat to indicate the current commit has a bug, and Git bisect good version 1.0 to indicate that version 1.0 was working. Git will check out commits to test. Use Git bisect good or Git bisect bad as needed, and then Git bisect reset when done. To find who changed a line and when, use git blame l1020 file.txt. To check repository integrity, use Git fsck full. Let us examine fixing Git performance issues. Common performance problems include slow clone, fetch and pull operations, repository bloat from large files, too many objects in the working directory, inefficient hooks or filters, an excessive number of refs, such as branches or tags, and network bandwidth limitations. To optimize performance, use a shallow clone for large repos with the command git clone, depth equals 1. Clean up with garbage collection using git gc aggressive. Use sparse checkout for large repos with the command git sparse checkout set followed by the directory. Prune unnecessary remote tracking using git fetch, prune. Configure git lfs for large files with git lfs install. Use partial clone with git clone, filter equals blob, none. Here are some Git debugging best practices. For prevention, commit small, focus changes, write clear commit messages, pull before pushing changes, use feature branches, set up pre-commit hooks, and configure .git ignore properly. For diagnosis, check the Git status first, read error messages carefully, use Git log to understand history, examine the reflog for recent actions, try the verbose flag for more info, and use Git bisect for finding bugs. For recovery, create backups before major changes, use stash to save work in progress, know how to use reflog for recovery, practice safe rebase techniques, understand reset versus revert, and document complex workflows. Remember, Git never truly loses your work. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.